Hello students, so today we are going to discuss this problem with you all. So this is a very simple, very basic problem, but let us see how can we solve it very quickly. So first I will show you an elaborate way to solve this question, and then at the end I will give you a quick way to calculate the current in the two branches shown in here in the two resistances R1 and R2. So the total current passing through this circuit is 1 ampere, and you have to find how much current will be divided in the upper branch and in the lower branch. So let us see how can we solve this question. So if you want to do it in an elaborated way, so we can find the equivalent resistance of the circuit first. Equivalent resistance of the circuit R, and these are two resistances in parallel. So I think you already know, for two resistances in parallel, to calculate their equivalent resistance, there is a shortcut way you can do, that is product of the resistances and divided by sum of those resistances. So these results come from your parallel circuit formula, 1 upon R equals 1 upon R1 plus 1 upon R2. So from there you get R equals product of resistances upon sum of resistances. This is a result to calculate the total resistance for a parallel combination of two resistances. So if you put the values here, R1 is 2 ohm and R2 is 3 ohm. 2 into 3 divided by 2 plus 3, so it becomes 6 divided by 5 ohm. So that is the total resistance of the circuit. So now we can calculate how much will be the voltage drop in this total branch, because the two resistances are connected in parallel. So we can calculate the total potential drop from here to here. So total V will be total I into total R equivalent resistance. So it will be 1 ampere into 6 by 5. So it is basically 6 by 5 volt. That is the total voltage. Now you know the voltage, so you can calculate current in each branch. So current in the upper branch will be I1 equals total V divided by R1. So that means 6 by 5 divided by R1 is 2 ohm. So this is 3 by 5 ampere. And current in the lower branch, that will be I2 equal to V upon R2. V will be same for both resistances because they are connected in parallel. So V upon R2 means 6 by 5 divided by R2 resistance is 3 ohm. So this will be 2 by 5 ampere. And you can verify that the sum of these two currents must be equal to the total current came to this circuit. So 3 by 5 plus 2 by 5, that will be 5 by 5, means 1 ampere current. That gets verified. So this was the elaborated way to solve this problem. But how can we do this problem in a shortcut way? So the shortcut way is, if you want to calculate the current in the upper branch, this is for two resistances in parallel only. So if you want to calculate current in the upper branch, you should write the lower branch resistance divided by total resistance into total current I. So this will be, if you put the values, 3 divided by 2 plus 3 into total current was 1 ampere. So it will be 3 by 5 ampere. And if you have to current in lower branch, then you should write in numerator upper resistance divided by total resistance R1 plus R2 into total current I. So for getting current in lower branch, you should write upper branch resistance in numerator, and to get current in the upper branch, you should write lower branch resistance in numerator, and in denominator, in both cases, you have to write the sum of the two resistances R1 plus R2. So R1 value is 2 divided by again 2 plus 3 into total current is 1 ampere. So here you get 2 by 5 ampere. So you can see that both results are identical. Whatever way you use, you get the same answer. So in an elaborated way, you can solve this problem like this. But if you want to get the answer quickly, then you can simply use this result, right? Okay, so that was all I wanted to discuss with you. Thank you very much. Take care and bye-bye.